has been a rough week. Okay, so we left off with example 4 yesterday. And I just want to review why we're doing this. We're not doing this just to divide and have busy work. Why we want to do this. Synthetic division allows us to find the roots, factors, another word for root is zeros, of our polynomials. Really, we use it for degree 2, but you don't need it. It's really for degree 3 and higher. Because degree 2 polynomials, we can factor. Nobody really likes to factor. If they're easy, they're fun. Degree 2 polynomials, we usually can factor or use the quadratic formula. Higher than that, to find all the binomials that make it up, or the roots of the zeros, you need to use the division to get it down to a degree 2. So, yesterday we talked about the remainder theorem, which said if I plug in the constant in my binomial, the remainder of that guy comes from doing the arithmetic. So, the remainder comes from plugging in that constant. That saves us time, and you're going to see that when we get to example 6. A lot of times you're going to have multiple roots to try. You don't want to synthetically divide and do all that work if it's not going to work. Our goal is to get a remainder of 0, because that's going to mean we have a root, we have a factor, we have a 0. So, is x plus 3 a factor of that polynomial? Well, you should know a polynomial of degree 3 should cross the x-axis 3 times. And it is made up of 3 binomials that are either going to be x plus or minus a constant. Well, the reason we're dividing is to get one of those binomials, so we can factor, quadratic formula, whatever, the other 2. The remainder theorem says, well, you don't have to do synthetic division right away to find the remainder. If you plug in what you would have put on your shelf and get a remainder of 0, then that means you can get a polynomial of degree 2 to finish finding the roots. Is this a remainder of 0? Can you, anybody with a calculator, type it in and tell us what you get? What do I get when I plug in negative 3? Anna. Oh, she is on fire. Thank you. Yes. Is that 0? That's the toughest question of the day. Is 6 0?
No.
Okay. So, since we did not get a remainder of 0, that means that x plus 3 is not one of the 3 binomials that makes up that polynomial. If I synthetically divided, it would get us nowhere, because since we do not have a remainder of 0, that is not going to give us the coefficients of the next polynomial. Does that make sense at degree 2? All right. So, moving on. We can use the remainder theorem to determine if these are 2 of the 3 factors that make that polynomial up. Okay, and we're going to even expand this a little more. So if I plug in negative 3, and if I plug in negative 2 to my polynomial, and get a 0, that means it is one of the 3. Now, for time's sake.
It's 2 times negative 3 squared.
It is. All right. So, well, you guys are hurting for mistakes. I don't mind giving it to you.
Mrs. Thornburg.
Yes.
Wouldn't that negative, that negative 2 be positive 2?
Oh. You are no longer hurting for mistake points, so I'm going to fight any that you come up with. Good job. Well, guess what? For time's sake, I'm going to tell you that each of these, when you plug them in, you get 0. So what that means is 2 of the 3 binomials we have found because there's a remainder of 0. Now, to find the third one, it's not going to ask us, but I'm going to do it because this is going to cover a couple things I want to talk about. We could use one of those to get a polynomial of degree 2. So, if I pick -3 and synthetically divide, who can find my mistake? This is a purposeful one, and if nobody finds it, I'm taking a mistake point off.
Can we just solve that?
Well, so I want to pick one of these to get a degree 2 polynomial to help me find that third binomial. But I did this second period or first period, and I'm like, wait a minute, something's wrong. So who can find my mistake by how I wrote this right now? It is not going to work out. If I do it the way I did it now, I'm not going to get the 0 that I should be expecting. What do you think, Jared?
Bringing down the 3.
Well, no, I will do that. Absolutely. I will do bringing down the 3.
Okay, well, let's see here.
You will get 9, right, but I can't even start it because I messed up writing it.
The line's not straight.
Well, no, but that's all right. Dylan.
Isn't brought down the -3?
No, because I do need the negative. I need the opposite. All right. I'm trying to help you. I don't want to take a mistake. My mistake is somewhere there. We talked about it, but it hasn't come up. What do you think, Kylie? Yes. So I'm glad this happened because we talked, but it hasn't. Do you see I go from a 3 to a 2? Oh, wait, that's not it.
Oh,
Mistake.
Nuts! Okay.
You made a mistake trying to show us a mistake.
Man, all
There was
right.
no mistake all along.
There wasn't one. April Fool's. No, there is one on another one. And now I can't.
That's the whole point.
Now I can't have you. Crud muffins. You guys are rolling.
I knew that was going to be it, but I'm like, that's not.
That's not. Yes, it's the next one. I got a little too excited.
We would get lollipops today.
Oh, you are not getting lollipops today. But okay. So, do you guys agree that this is the degree 2 polynomial? Do you agree he is 3x squared minus 7x plus 2? Correct? All right. Now, we only need one more binomial. At this point, you could factor. I hate to factor. You could quadratic formula to see which one we're missing. Or, since I have another root that works, you could synthetically divide with these coefficients. Does that make sense? So when you get to your polynomial of degree 2, you have 3 options to find the other binomials. If it's a coefficient of 1, I certainly would factor. You could do the quadratic formula, or you could synthetically divide. If I synthetically divide, right, I would get a -1 and a 2, negative. My final polynomial would be 3x minus 1. Does that make sense why we did that? All right. If I did the other ones, I would get the root of a positive 1/3, and then you would plug it into there.
So could you do the 2 first and then substitute for the -3?
You could, I think, if I understand what you're saying. Yep. But the question said find all the zeros. I needed that to find the zeros. All the zeros then would be 2, -3, and 1/3. And you should expect 3 zeros from the 3. Huh? Yeah? Now, you want to work smarter, not harder. I honestly, in the next ones, I'm not going to give you 2 of the 3 binomials. I'm going to show you a way to find them. Sometimes that's more work. Sometimes I would just rather use the quadratic formula to find the one. But it's totally up to you. All right. Crap. This is the one, maybe. Okay. When I give you x equals k, you know to put it back into that binomial form to get your factor, or vice versa. And that means our remainder comes from plugging in k to the binomial. If r equals 0, we just talked that x minus k is a factor, and that we talked when we solved, that's an intercept or a root. That's all a review. What? Just what we just did. We just talked about it. If it is a root, that means it's a 0, right? It's where it crosses the x-axis. But it's not always going to be nice like I gave you in the last example. From here on out, I'm just going to give you the polynomial and say, find all the zeros, find all the roots, with nothing. You should remember this from Algebra 2, that if you take all of the factors of the end guy and put it all over the factors of the front guy, those are all the possible values that would give us a remainder of 0. You guys remember that, the p's over the q's? So if I look at factors of -6, who can tell me 2 of the 4 factors of -6? Any of the 2? What do you think, Kim? -1 and +6, give me a -6. How about a +1 and a -6? Right? Do you agree 2 and 3, either a positive and a negative or a negative and a positive? Right? You have to account for all of them. 1 is easy. -1 times -1, +1 times +1. But all the possibilities come from taking all those p's over all the q's. And you can simplify it. So all of those over 1 just mean possibly 3 of these give me a remainder of 0. All you have to do is find 1, because then you could quadratic formula or factor. If you don't want to do that, you have to find 2 that work. So when I don't give you anything, you have to find the ones that may work. Now, eventually, when we get through this, we're going to just use our calculators to help us, but we got to learn it first. So, would I be nice by telling you which one works instead of testing all these? Alrighty. When I plug in -1, I get a remainder of 0. When I plug in -1, that guy works. So what do you think you do if you find one that works? What can I do with it to get a degree 2 polynomial? Synthetic divide. So, if I put that -1 on my shelf, this is where I was trying to get you. Do you see how we go from 3 to 1?
So you plug in the 0.
You got the 0. That's totally backfired. You know what? Don't tell me any secrets, because I can't keep them. Okay. You got to hold the place. When we divide, I get a -1, a 1, a -6, and a 6. You should not be surprised you get 0, because we already tested it. And wouldn't that be a lot of wasted work to do that every time to see if it worked? I mean, that's just a lot of work. Who could tell me my polynomial then of degree 2 here? What is it? X squared. Go ahead, Kylie. Okay. Now, the directions say find all the zeros. Well, to find all the zeros, I need all their factors first. I know that x plus 1 is a factor because the -1 worked. Okay? What would be the best way to get the other 2 factors or zeros? Is that an easy one to factor? Yeah, it's a degree 1. You could quadratic formula, or you could find another one of these to divide again. But seriously, if you can't factor this in like 2 seconds, we have a problem. So, the three factors are -3 and +2. What would all my zeros be then? Can somebody tell me where they would all cross? Kylie, I saw you first. Shayla, you can confirm. Shayla, agree?
Yeah.
All right. So, right here you had a choice. We factored, but you could do the quadratic formula, or you could find another one of these to work and synthetically divide it one more time. If there's one of these on the test, I will not give you one that has like 1,500 p's over q's. So it'll be easy, just like this last example, and then we're done. We might
Yeah,
even.
I was gonna ask them, like, so you literally have to plug in like positive and negative like every single number.
What you could do, now here's to work smarter, not harder. Plug it in your y equals. Use your table and find out which ones, when you plug in, pick your x's, find the zeros. And then you could just show me that, f of -1 equals 0, and tell me you use the table on your calculator. That's a work smarter, not harder thing. So this guy, can somebody tell me all the possible p's and q's? What gives me a -1? -1 and 1. So how about a +1 times a -1 and a -1
Please
times
excuse this interruption.
+1?
Augie Towers, please report to the office. Augie Towers, please report to the office.
Do you agree the factors of a +2 are a +1 and a +2? -1, -2? But this is where people make mistakes. You got to get all the p's over the q's. 1 divided by 1 is 1. But what's the second one going to be? 1/2. Don't make that silly mistake. So this is like one I would give you on a test. It's not a lot of choices. For time, I'm going to tell you -1 works. I don't know why I always want to put p of -1. -1 gives you that 0. This guy would have 3 factors, so I know that x plus 1 is 1. And just again for time, if we synthetically divide, do you agree I need a placeholder there for the x to the first power? When we divide, your coefficients are 2, -1, or +1, and -1. I'm just going to take out that step to show you that this is our polynomial degree 2. Oh, you can make me do it. So -2, that's a 1, right? So negative times a positive is a negative, adding.
How's it secret? Oh, never mind.
Okay. All right, but you're paying attention. You're trying to get those lollipops. This is it. If I make it through this, you don't get them. Guys, this guy factors. He factors into 2x, what is he? 2x minus 1 and x plus 1. If you don't want to factor him, you could find another one of these that work and synthetically divide those. But your zeros are -1, 1/2, and -1. So you only have to write it twice. That means this factor occurs twice, which means it has a multiplicity of 2. So in the graph, it's going to bounce off of -1, just adding on. But your homework